Today let's talk about Atcoder regular context 185 problem C. First part is description. You are given an integer array AR. The length of it is n. You are given another array x. What you need to do is choose three elements from array and make the sum of the three number is x. That means you choose IGK, so ARI plus ARJ plus ARK equal x. This is what the problem asks to do. The limitation about the integer is x between 1 million and n have the same limitation x. So this is the limitation about all number. Next part, let's talk about the solution. And first of all, this problem uses a very important and distinct algorithm that called convolution. Let's talk about the definition and influence about this algorithm. You have two integer array a and b. The length of them are m and n respectively. You can receive an integer c through this algorithm. Every element equal, okay, let's use c n, okay, change cx equal the sum I plus 0 I equal x ai multiply b x minus I. This is the definition of array C. That means every element of C is the sum of ai multiply b x minus I. From I equal 0 to I equal x. This is the definition of array C. You can get the array C. The time complexity of this process is time complexity. Okay, let's talk it a little. After we know about this algorithm, we need to use this algorithm to solve this problem. More specifically, if you don't know about this algorithm, it's very hard to solve this problem. So next part, let's talk about this problem. What you need to do is make three integer equal x. So we can travel the every elements and to check if the x minus ARI. We can check if this is available to be the sum of two elements in this array. That means it is available. We need to check it is available J plus K. This is very similar with the algorithm we have talked about. What is the difference? What is the difference is simple. What we need is a plus, but the original symbol of this original algorithm is multiply. So we can transfer the plus to multiply. So what we can do, we can transfer the array AR to the frequency array. That means frequency X means the number of value X. That means number of value X appears in array AR. So we can get frequency array from original array. So if the Cx, if this is larger than 0, that means X is available to be the sum of two elements in array. If this is 0, that means X is not available to be the sum of two elements in array. This is so we can get C equal evolution Q. So we can get the function, we can get the array C. The definition of C is this. That means if Cx is larger than 0, X is available for sum of two elements of array. So this is so for the solution of this problem, we can check every X minus ARI and check the C minus ARI. Check this value for I0 to I plus N. Check the C X minus ARI. Check this is available. If this is, that means the value of it is larger than 0. If it is larger than 0, so we know we can choose two elements in original array to be the sum to this value X minus ARIJ. If we can assume these two values is J and K, so the answer will be IJK. And this is almost all about this solution, but it is also consuming too much time in this problem because there are many repetitive situations. For example, in the original algorithm convolution, A and B are two different arrays, but in this situation, we use the frequency array. They are the same, so we will use one element two times. For example, let me F1, F2, F3, Fn. This is array A. For array B, F1, F2, F3, Fn. Maybe we will use this element F3 two times or three times or more. We will use it more times, but actually we cannot use it many times because I, J, and K, because these three elements should be distinct index of array. So this is the difference between original evolution algorithm and our actually solution. So we need to write some tricky code to avoid this competitive situation, this special situation. We need to write some special code to avoid this specific situation. As a result, we can reduce the consuming time. That can help us to resolve this problem. There are several code that can help us to reduce the consuming time. Maybe we will use the same elements 2 times, 3 times, and more. The method to reduce consuming time is to avoid the same situation, the situation that we use the same elements many times. Okay, this is all about this problem. This is all the solution about this problem. Let's talk about the third part. The third part is complexity. First is time complexity. For the convolution part, the complexity is x plus log x, and the solution part, the last part, is on. So the totally time complexity is on plus x log x. We also can write it O max n x log x. For the space complexity, it should be, for the first for the convolution part, the space complexity is O or multiply 2 multiply x, and the last part we don't need extra time, so we don't need extra space, so the space complexity should be n plus x. So this is the sum should be n plus x. It is also can write max. So this is the space complexity. It can be n plus x or max x dot n. This is all about this problem. Thanks for your watching.